Hello everyone, welcome to the channel, welcome to the workshop. So I've had a lot of complications with my recording devices as of recent, and I've lost the intro to this video, so I'm having to re-record it. So let me just set it up for you. Imagine it's raining outside. It's a nasty day, and I've got some priority one inside work to do. It needs to get done. See you in the workshop. If you were to look around my shop, you would probably agree with me and say that the priority should be probably cleaning up your shop on a rainy day. Be a good project, but I've got more important things to do, and I keep hoping somebody will just show up and clean my shop for me, but hasn't happened yet. So, in my opinion, one of the most essential or important tools or pieces of equipment in my shop is an air compressor. Use it all the time, and whether you have a wood shop, just a regular workshop, an auto shop, a welding shop, or whatever, just a garage, use the air compressor all the time for all kinds of different tasks. That being said, my air compressor went kaput about a month ago. Okay, here's the scoop. I had a big long intro recorded for this video, and I didn't really do a very good job with it, so I'm going to summarize this the best I can. Here's my predicament. I've got two air compressors. This is air compressor number one, what I will call air compressor number one, and it does not work anymore, or it doesn't work at the time that I recorded this video. It started screaming about a month ago all of a sudden, and I shut it down. Turned out later it's just a bearing that's going out, but I'm kind of already in the mindset that I'm wanting to get a bigger, better air compressor, and I don't want to buy another one because I just bought one for my garage and they're getting extremely expensive. So this air compressor is out, and trying to come up with a different solution for an air compressor to replace this one. This is air compressor number two. Air compressor number two is basically almost brand new. It has very little hours on it. It was in my garage before I replaced it with the compressor that I said I just bought for my garage. I have never liked this air compressor. This air compressor has always been junk. It takes forever to air up. It is unbelievably loud when it does. I have never liked this air compressor. The SCFM on it is poor to poor, pitiful. So I want to get rid of this air compressor. I want to gut it, and I want this air compressor gone. So in comes the solution to my video that I'm getting ready to make. So here's my idea. Can I convert that air compressor motor and pump to a 220 volt motor and air compressor that is oil cooled and belt driven, like the new one that I upgraded to in my garage? So that's the project. Let's see if we can make it happen. Into the rescue comes the freight of harbor. So I bought a compressor motor. It's a 3 horsepower, but this is a 220 volt, whereas the one that I'm gonna gut is 120, and a 3 horsepower pump to go along with this. So I'm gonna have to do some manufacturing. I'm gonna have to gut that one, and some of the obstacles are gonna be I think the switch is gonna be fine. I'll just run it off one leg off of this, because this will be 220 from the breaker panel. So the other obstacle will be just wiring this 220, because I don't have a 220 plug. I've got a 220 plug for my table saw and my planer, but I don't have an extra 220 plug for the compressor over there. So I have to run a plug, actually probably put in a new breaker in the panel and run a plug down for this. But I'm going to have to tear the old pump and motor off. I'm going to have to replumb some of the air components, and I'm gonna have to build a base to mount this stuff on top of it, which is gonna be kind of a little top heavy, so I'm gonna have to worry about that. and go from there. So let's first start with unboxing some of this and see what some of this looks like. So about what I expected. Pump, it's pretty heavy. Motor, it's pretty heavy. Appear to be pretty heavy duty. We'll see how they work out. Air filter, air intake. Here's your air output. So I'll have to plumb this or pipe this to the tank. I will have to get a pulley for this shaft. That is a 5/8 diameter shaft for your bore and your pulley with a 3/16 key. There's a V-belt. This is your oil fill on your motor, and there's a sight glass on the back, and then here's your switch. So I will read and see which direction fills, maybe either or, and also the motor when you wire it up. Is it going to spin this direction or the opposite direction, depending on how you wire it up? So whenever I build my platform will depend on which side this needs to be on. So we'll do that here after a while. I'm not going to bore you with reading the directions, and then we will gut the old compressor. So I want to back up here just a second real quick and re-emphasize that this was a good air compressor. I've had this air compressor for probably close to 15 years, if not more, and I have put a lot of hours, and I've used this air compressor a lot. So this air compressor has been a good air compressor for me. This air compressor, like I said, is junk. I've already had to replace the pressure switch on it and the drain valve on the bottom, and this thing has got well less than 100 run hours on it total. I am not affiliated by anybody, but this air compressor so far, since I've owned it, is awesome. This is a badass air compressor. It is definitely worth your money, which is about $200 more now than when I bought it a couple years ago. So what am I doing in the meantime for an air compressor? You're gonna love this. So this is as loud as this air compressor gets. This air compressor belonged to my grandfather, and it is homemade as homemade gets. I have no idea what that tank originally was, or if he made it, no clue. I'd say that he built this probably in the 60s or 70s. Motor, 110, pump, oil cooled, belt driven, and the switch up here is, I think it's 100 psi before it shuts off, and I've had to kind of rig up some connections so I can connect the hose to it. But this is the air compressor that I'm using at the moment to make do until I get something else fixed. Later I'm going to clean this thing up and see if I can read. This says Frigidaire number 1124665. I'm kind of curious what that's off of. There's also a reed plate there. Clean that up later and look at it and see what this came from. So the other compatibility issue that I had to think about is that pump is rated at 145 psi, which is right about where I want it to be, because this tank is 150 psi tank. So that is compatible in my eyes. So let's start tearing this thing down. Okay, so we got everything broke down. I'm gonna try to reuse that switch if I can. So there's gonna be a few obstacles here, but the main obstacle is how to mount those two, the pump and the motor, to this situation, which I'm gonna have to do some manufacturing. But the main thing is that switch. So this is your output, where the switch is, and where you connect your air fitting, air hose, and this is the input. So whatever pressure your motor is building needs to feed to this. So I'm gonna have to build, I've got some plate, steel plate, and I'm gonna have to lay out my motor and my pump how I need to on my workbench, draw out kind of how much area that's going to have to cover or require, and then figure out if I can lay this in here where it's not blocking this and it's not hitting my switch up here. So I might actually put my switch back on just for measurement's sake, and then either bolt that plate to this plate or weld it to this plate and then bolt the motor and the pump to the plate, and then later worry about my wiring and my plumbing. I need to be thinking about it, but as long as it's not obstructed, I should be able to route my pipes to this, and then my switch will be here. So I'm having to do some measuring here, but first off, I'm realizing that this is quite a bit narrower space than what I thought it was going to be. So I'm gonna have to keep that in mind. And then also, because of the pulley on the front of the pump hanging down and being as large as it is, I'm gonna have to take that in mind, and I'm probably going to have to build this up quite a bit so it fits and doesn't hit, and it can spin, and the belt and everything, nothing hits and nothing catches on anything. So I'm using the front edge of my workbench just kind of as a guide to kind of maybe walk myself through this in my mind, figure out what I got to do here. Multiple things to think about. Once again, this is going to have to be elevated just because or it's going to have to be hanging over to the far side of where my switch is, so it's not hitting the switch. Safety concerns, this thing's spinning, getting your hands into it while it's actually running. I don't know if I'm going to be able to build a shroud around it. We'll have to figure that out at some point, possibly. So using the front of the workbench kind of as an alignment, the mounting holes on this are actually matching up with the mounting holes on the motor pretty well, and it's not that big of a deal, but just to kind of simplify things at some point whenever I go to do this, if I line this up and I make a mark on this yellow cap just for sake. Alright, so I'm roughly maybe a ½ inch in. It is 1.25 inches. So the pulley I have will have plenty of room. Yep, and it'll still be on the keyway. So lining those holes up on the front should be good. Left to right, I guess I could spin this around. So the diagram does say that the motor needs to be on the right side. I'm assuming this turns clockwise and assuming this turns clockwise. This is actually reversible per the manual, so I could wire it backwards and it would spin the motor the opposite direction, which would be fine. But for this project, it needs to spin clockwise. This needs to spin clockwise, and then we'll be good to go. The distance on my mount, 8 inches, well actually if I had an 8-inch plate, it will work fine, but I have to factor in these hanging over this direction approximately. Let's say the front edge of my table is the edge of my mounting plate, so I've got 3.5 to 4 inches, 4 inches of play off the front of that plate that I'm not going to be able to, it's not going to be able to hit that, my switch. So I'm going to work on that in my head, and we'll try to develop a mounting plate. We'll try to figure out. So another thing maybe I'll do, in this distance here, left to right, is kind of arbitrary because I could probably get, they make V-belts in all different sizes. So my motor actually has slots this way, so I can move it left and right to tension it. And I don't think I'll have to worry about making a slot back and forth to move that, as long as those front ones are lined up. So that should be good. And once again, they make belts, V-belts, in random, or all kinds of different miscellaneous lengths. So I guarantee I can just find a good length and then tighten it to where I need it, hopefully. And when I get closer to that point, before I drill my holes to mount this, I'll probably figure out about how far that is, and then or what length of belt I'll need, and then maybe move my holes accordingly to whatever belts I can find. So left to right right now, I'm going to make a mark right here on my table, and a mark right here, and that is going to put me roughly left to right. I need a little hangover, maybe a 1/2 inch, 20 1/4, about a 1/2 inch hangover left to right, and we'll see where that puts us.
2,000 years later. One eternity later.
I wouldn't bore you to tears with the amount of filing that I had to do, but I got them all done. Okay, this is the wrapping up day 2. I got the mount, the gray mount, secured to the tank, the plate, and I got the pump mounted to the mount, and I've got the motor secured there. Everything lined up good. I'm having to, one of the things I still have to do is I ordered a pulley. I'm waiting on the pulley for the motor. I'm gonna have to get a belt. I can adjust this a little bit to slide in and out to determine what length belt I need. I'm not a real big fan of how close this is to here, but heck, I built this up quite a bit. I'd have had to build it up a lot more to get above that. So I got to, at some point, I'm gonna have to build a shroud around this to protect it. Get your hand in there, because this is where you plug in your hose, and it's awful close. So I'm gonna have to figure out a shroud of some kind to protect it. I need to get some oil to fill this up, some compressor oil, straight 30 weight. And the cord that was on the previous, so this is the leg that would run to the box back here, and it is not quite long enough. It's close, but not quite long enough. So I need to get, or just cut a piece of extension cord or something, and make another leg to run from the switch up to the motor. And I'm going to still need to plumb from the pump output somehow over to the tank input. So I'm not quite sure how I'm going to do that yet. I thought about running it to this side, but then it would be in the way of these bolts if I need to get in there. I was thinking about running it down and underneath the switch box here, but the wire comes in. There's a hole on the bottom down here for where the wire goes, so that will kind of be in the way. I could run it down and through my framework here, but I really didn't want to have to do that, so I'm not real sure, and I don't want a whole big mess of running around, so I'm not real sure what I'm going to do yet. I'll get it figured out. I guess I could run it up and over. I'd almost rather run it up and over to keep it out of the way than anything else. We'll see. It's not like if I did it, I couldn't redo that part. It's just copper. The other thing too is this is 3/4 MPT. Be a couple days while I order some stuff and get some stuff in. Be a few seconds for you. But I think it looks pretty good so far. I don't think it's top heavy. Once again, I'm gonna have to get a shroud for it, or build a shroud to protect it. But it's not too top heavy, even though that pump and that motor are pretty heavy. But I think it's turning out pretty good so far. So I've run into my first, I'm gonna call it a hiccup, obstacle for the moment. If you can see, there is the outlet nipple right here is what is defined as a 3/4 inch 14 thread NPT pressure fitting outlet, and the locking collar that came with it screws on there just fine. So the first thing, my first obstacle, is choosing what pipe to use to go through this compression nut. Well, the first obstacle is using my calipers. This is actually not even 3/4 inch. It's actually just a fraction under, 0.74 by my digital calipers. All right, so this is where I'm going to utilize you guys. What would you do in this situation? 3/4 inch copper, and even the flex copper is defined as 3/4 inch inside diameter, not outside diameter. So the outside diameter is closer to like 0.83 or 0.84, which would not even come close to being able to fit into this opening. Also, most flare stuff, like I have a flare kit and I even got a new one, it says that it will do 3/4, but it's 3/4 inch outside diameter, not 3/4 inch inside diameter. So this is 3/4 inch flex, and the outside diameter is way over 3/4, along with regular copper straight pipe. So no matter what, these are not going to work with this. So what would you guys use to fit through here and to flare? What kind of tubing? Because I've looked, I've actually went and talked to a few people and asked, and they're all unsure. So what them and I have decided on is just to choose a regular copper 3/4 inch 14 fitting. Okay, so went to the store. Let me lay this camera down real quick. So this is basically the predicament that I've run into. I went to the store looking for what would thread on. So this is a piece of 3/4 inch. It's just an accessory nut. But when I went to the store, I was basically finding what this compression collar would thread onto. So it threads onto that just perfect, right? So this also threads onto that just perfect. So I thought this is what I need, because it has the same thread as this. This will thread onto the pump compression fitting. So when you go to the pump compression fitting though, this, and I've sat here and messed with this thing forever, it will not thread on there. When it tries to thread on there, it gets cross threaded. So yes, it's possible that I got a bad piece of copper from the store that has bad thread, so I guess I could go buy another one. But to test it before I went to the store, I have a piece of 3/4 inch. Okay, so enter said piece of pipe. So this is 3/4 inch black iron pipe, and the piece of copper, well, I'm gonna look like an idiot on camera. There we go. Threads on just fine. Okay. So I'm thinking, well, I don't know. This threads onto this, but it won't thread onto that. This, so I double checked this again. It threads onto that just fine. So what's going on between the copper and that compression fitting? And honestly, I think it's just a small amount of flare that's on that compression fitting. You can see it, just this small amount of flare. I think it's just keeping it from wanting to thread on right. So here's what I've decided to do. So I can't stand being defeated. So I want you guys to give me some input on what I could use to fit onto this as far as pipe goes and still use that compression nut that came with the pump. I know there's all kinds of other options, but they sent that compression nut for a reason, and I know this stuff comes from across the sea, and I bought it from the freight that comes out of the harbor. But and it's not always the best, and it probably doesn't have the best quality inspection and quality assurance. But I just can't imagine that there's not a solution besides what I'm going to have to do. So what I've decided to do is these nuts here, I'm going to unfold. I'm going to undo this manifold. So here's the manifold undone from the pump. And I don't like being defeated, but I do pride myself in improvising and overcome. So in the process, I took this thing off thinking maybe I could, because I have some taps and dies, and it is the 1 inch 14 tap. So 1 inch 14 goes into this perfectly. Okay, I just cross-threaded it. It also goes into this. So I have a die that's 1" 14 that I tried to fit onto this to maybe clean the threads, but it won't even go onto this. So I do think that it is the flare portion and maybe the first thread that's becoming an obstacle. So I thought, well, I can actually cut that portion off and then start my threads again, but I don't really want to do that, because if something goes wrong, then I've runt this connection. But then I realized there's another connection here. So I've really just kind of boxed myself in. So I stepped back, started thinking outside the box a little bit, and I thought, well, what else can I do? Well, there's another 3/4 inch. So I think the solution to this is I have a 3/4 to 3/4. I'm just going to screw that in, and then I'm going to take my 3/4 inch copper line, screws on just fine, and then I will put the manifold back on, and then I will just solder from this point to my tank inlet. So that's my solution, but surely there's another way to go about doing that other compression nut. Let me know your thoughts, some ideas on what else I could have done, but this is what the plan is for now. Okay, so it's been a couple days. I went to the store and I bought some supplies. I also put the manifold back on here to kind of look at some of my distancing, and it's kind of hard to see. But when I put this nipple on here, it brings this down very, very close to my wire box on the back of my motor. And I don't like that. So I found some belts too. This belt is probably what's going to work. It's a little bit loose right now, but I need to slide the motor this way with the mounting brackets to kind of tighten it up. So that'll tighten it up, and that will move that away from the manifold. I also did some calculations with the owner's manual on what size pulley, because I just bought a couple different size pulleys. I didn't really know which size I needed. I need to actually get one by their calculations just a little bit. It's like 3.6 inches is what the pulley needs to be, and I think this is a 3 or a 2.5. Anyway, that will make this size larger, which will also tighten up the belt just a little bit too. But I don't like that. So my other idea is I went to the store and I bought a 3/4 male, and I think I'm going to take my 3/4 male, go up where the nipple is, and then turn my 90 directly out of this and bring it out more this way, then drop down and run pipe back to the back side, which will get me there. I know it's a lot of talking, but let's just see if that works. Also, I have to take, I'm gonna have to take this motor off and wire it. So I'm wanting to do this stuff before I take the motor back off. Also, I need to take the switch off, and this pigtail, like I said before, is not long enough. So I bought some heavy gauge extension cord that's a little bit heavier than the cords on it. So I'm going to go ahead and replace the cord with the plug and this pigtail that goes up to the motor off the switch with a little bit heavier gauge wire. I think that this was rated at 15 amps and this was rated at like 18 amps. The motor's only 12 amps, so this cord would actually do the job, but I'd like to go with something a little bit heavier. Also, I went ahead and got this area cleaned out, pulled my air compressor out, cleaned that up. It's actually working a little bit now. There was a bearing that had all kinds of gunk in it, and that's what was screaming so loud. I got a plug in for the new compressor and got a new breaker in the breaker panel, and ran a wire down and mounted a plug, so whenever I put my air compressor here, I'll have something to plug it to. So let's work on that copper fitting first, and then I'm going to pull the motor off and then do a bunch of wiring. Okay, so I dry fitted some pieces together. I've got another 3/4 elbow coming down to a 3/4 to 1/2 inch reduction down to a 1/2 inch elbow, and that will turn my corner to go back across. That brings me right down, right above where I will need to be to get underneath the motor wiring mount area. So I'm going to go ahead and solder this together, and then I will come back and I will solder this connection here, and then I'll work on bringing my connection down. So here we are dry fitted. This connection here has not been soldered yet. I'm trying to get this around the back side worked out. So we'll come around this side. Try not to make anybody dizzy. Got to come down 90 and over, because I've got a union here too, because the outlet, actually the way that this is welded to the tank is at a slight angle, so it makes it kind of awkward. Doesn't come straight out, so I could tee in. Actually, luckily my pipe was out of line just a little bit, and honestly that is paying me dividends, because it made all these other connections quite a bit easier. It's almost like that happened for a reason. So I'm going to take this apart and I'm going to solder these together. Then I will pipe thread this connection back in, and then I will solder the rest of the connection. So this was actually a piece of copper that I salvaged off another. I've got a array of copper pipes laying around from stuff that I have redone over the years, or my dad, and this connection is already, this 90 is already done, so I'll just need to do these and that one up there. Okay, so I didn't do anything complicated here. I just wired up my plug that adapts to the wall plug that goes to the breaker panel, and I replaced the slightly lighter gauge wire with a little bit heavier wire, and I just went black for black, white for white, ground for ground. That's all I did. So I have 3 wires here, and if you look over here at the wiring diagram that's on the motor, it's also in the owner's manual. Line 1 on a 240 system gets wired into P1, which is this single. Line 2 gets wired into T4, T5, which is this double connection here in the middle, and then the other wire stays as is and just gets a cap put on it. Okay, let's test it. The breaker is on to the plug. I'm going to plug it in. The switch is off, so it shouldn't come on if it's wired correctly. All right, everything so far so good. I'm gonna flip the switch on and let's see what happens. Switch is off. It's got some torque. Tried to jump off the... It is twisting, or it's turning, the motor's turning the right direction for when I mount it to spin the pulley, so it's good. I think we are good to go. That's me shutting it off, and then that's the motor spinning down. All right, I think we're good to go. We'll hook it up to the system and we'll see if we can make some air. I got the belt on. This one's a little bit tighter. I don't want to put too much tension on this shaft coming out of the motor, causing excessive wear on the bearing in there, pulling it in. So I feel like this one's too tight. The other one I had on was a little bit too loose. I might get one this size, but this is too thick. This needs to be, I think, 1/2 inch. This is 5/8. Or I could go with the other belt and go with a little bit bigger pulley maybe, so I might get a bigger pulley, so I might try that. I need to fix this cord down here out of the way so it doesn't get into this. I might work on that real quick, and then I think we'll be good to go. Plug it in and try it. Boom, instantly got something made there. All right, so other than a protective shroud around this, obviously, which I will do later, everything should be good. Let's plug it up and see what happens. All right, she's in place, plugged up. Let's give her a go. Contact. Okay, we're going to stop there for just a second. I got it up to 40 psi. I'm going to hold there and see if it maintains, and if I get any leaks in my system. But the big thing is, the reason I stopped is I just realized that this dummy forgot to put oil in the motor, which is very important. So we'll put some oil in there, watch to see if that drops, and then we'll max it out and see if the switch shuts off where it should, and it should be good to go. For what it's worth, it took exactly 1 quart, and it's shows in the sight glass out here on the back side, halfway exactly. So it's been about 20 minutes or so. I've leaked off maybe 1, maybe 2 psi, so that's okay by me. If it gets worse, I'll noticeably know where the leak is, if there is a significant one, or maybe it's just the back pressure into the pump that's just slowly leaking down. Anyway, let's kick this thing on and let it run for a little bit and kicked off at 140 psi, which is exactly where I wanted it to kick off at. So the switch seems to work. Pump obviously got a little warm because it's compressing air. It took a little over maybe 4 minutes to go from 40 up to 140. Not quite as good as what I was expecting, but it's noticeably quieter. So I am leaking a little bit of air out of this. There's a small hole on this side and a small hole on this side, so it's almost like it's meant to leak air. I looked in the owner's manual. There's really not a lot about it. The expanded parts view just says it's an oil breather. So if any of you guys know if that's normal, if that's what it's supposed to do, let me know down in the comment section. But otherwise, that's it. I checked all the other parts, sprayed soapy water on everything. I'm not leaking air anywhere else except right there. And I was at 140. I'm down to 120 over maybe 5 minutes or so. So that's the only place I'm leaking air from. Anyway, we're going to go from there, and I'll probably work out that solution, or maybe that's normal. And appreciate you guys watching. So awesome. I'm going to generally call that a success. I got a few things left to improve on it. I want to work on that belt, maybe a different pulley, and get a protective shroud around it, but I'm going to call that success. I'm glad it worked out, and that's a wrap on this video. As always, give me a thumbs up if you enjoyed the video, leave a comment, share the video, and I need subscribers on my channel, so please subscribe if you haven't already, and I'll see you on the next video. Thanks for watching. Have a good day.